I must.
You must share screen.
Yes, I'm working for that. Are you able to see my screen?
Yeah.
Okay, not only this. Another. I want to just did I open my camera?
Yeah.
Are you able to see me on my screen also?
Yeah, we can see your presentation.
Okay, so you
can start.
Okay, so basically before I would like to start it, I would like just to thank you so much for being accepting my paper, and as well as thank you so much. And also I would like to thank my doctor because he's with us. So my paper will be automated evaluation of virtual assistant in blue and the rouge score. I'm a student from Altabat University, department electrical and computer engineer. And my doctor is the professor of Zeta. So let's go. Our work, it will be divided in 4 parts. For the first thing, we will just talk about introduction, and then experimental procedure, how we use it, and related work, and the user satisfaction. And also, we would like to finish our work by conclusion. The first quick thing, IoT is a bridge of communication that is a purpose to encrypt, decrypt, and store information and share also the data by the user. The main thing about IoT is to convert the sensor and the point to be intelligent and make a critical decision in short time. Not only this, the data, it will be exchanged here by dialogue system via the user telephone or anything that the user wants to. Before to go further, the history of evaluation of the system. History, the quality of dialogue measurement, it was being used by Turing text. It means that it's only used but large interpretation of the user. But it was, at least there is a much more critical point to be followed by it. After this, there is some researcher has been developing and thinking that dialogue system evaluation, it will be much more important if it will be used by neural network domain classification. But in fact, that point, it will be much more harder because it's need more and greatest data to be evaluated with it. After this, there is some person, he thinks that autoencoding, it will be the most important linguistic performance to define which or not the quality of the user and how much that both or maybe that system has been a large information to understand what the user is saying or not defining to. After all of this, it's not the most important thing. There is some others which in error rate and defining how much the error evaluated of the theta has been used in the system. After this, there is some researcher go further and converge for the overlapping for the work, how much the references it's used and how much the test it will be used. And after that, the comparison will be used and define how much the performance of the system will be used. Not least, but also it's a blue and rouge metric has been used to define the quality of the performance of the system and how much that both is being able to understand the user based on a metric, and the overlapping between those information that will be at further. There is an example that I will show you how it works perfectly. Rouge and the blue metric has been the most important thing that has been used in this paper, because the other they just use in the blue, but in our cases we just add rouge because it's based in precision, and the F1 score it's mean more important. After this, there is one question that will be asked here on where is the novelty of our work. In our work, we create a virtual assistant based in IoT domain that has been collected through a large that data, and then we just complete it by communicating with the humidity and temperature due to IoT domain. And not only this, the other thing, the boats bring the last measurement has been collected due to the smart system. The quality of the system has been measured of the overlapping diagram blue and rouge to evaluate the most performance of the system and how much our boat has been able to understand and communicate with the user. Comparing all those results has been not only defined by ours, but also was being compared with other previous work to define how much our work it's being good or not. And not the least, the user certification has been provided, but the real user based on the Paradise method, and it's like a survey that we'll be discussing later. Before to go further, it will be much more important if we would like to know the main structure of the boat and how it's work basically. The structure of the boat has been, as I mentioned earlier, the IoT gather the information from the sensor and measure all the information through those buildings and establish the last measurement of temperature and humidity sensor. The model has been used is the LoRa model because it's convey much more quality. I mean, it's more a good thing to use it because it's energy saving. The IoT is the command link between the receiver and transmitter because it has a double mission. It's not only machine-to-machine communication, but also it's a data gateway saved and send all the information through the IoT network layer. Our bot, or maybe the chatbot, contain several feature. The first thing is the chatbot engine, how it works, how it provide, because there is multiple things you can define it. The platform that we visit here, and is the machine learning, and the channel we use it's Telegram channel. Okay, the scope of the use in all of this is because the battery is operation time, and the management of this has been to monitor the environment of the building. Not only this, the IoT is provide the increased comfortable of a human, and it's more to provide intelligent automation for human. The case the data is the optimal factor to reduce those energy and provide much more smart city in our environment. For this thing, I would like just to show you how my boat is really working. Okay, let's see, where is it exactly? Okay. I'm not able to see this also. I'm really sorry. Okay. Wait. Yeah. Are you able to see it?
Yeah.
So yeah, the boat is running. Let's see, terminal. Yeah, it's running. Okay, you just, so for example, you can just write here, can you just give me the temperature, or maybe you just click here and it give you the information. Let's say thanks, and it must give us the hour. Thank you. Oh, you are welcome. You are welcome too. So let's back here after this. You see how really it works. So the boat, it's not only this I would like to show because I think let's be here in, I want to show something else. Yeah, our boat it's could contain those feature. It's convey ask of temperature, humidity, how it work, and the response sentence and the story, how I mention it, how I build it, and automatically there is if I say hey, it provide you hey. This is the syntax of how it's work. Okay. After this, we just would like, after we compare it, I calculate the Bloom metric. It's based on precision. You see that, okay, here, you see there is, our model has provide the blue because we use here first 1 gram because it's much more effective. And there is another person here, it just, provide 0.15, even it use BBC data. The language is it's Arabic. Our main language is English. There is that person also, it's use it DVC-net model, and it contains 0.30, even it contains a large data is also in English. And there is, you can see there is even those person use much more large data. Even those score, it doesn't achieve the same score that we achieve it. Even you have, we have a small data that we has been used. It means that our boat contain performance and able large quality to define what the user said. And after this we just here we would like like just to move for rouge, because rouge it's defined much more precision, because blue it's only used for precision, but the rouge it's only used because there is a precision and F score and recall. It's mean that's much more preferences used. For this thing, I would like just to show you how it's really work based in our coding. So I didn't mention earlier how blue has been calculated. It will be here much more important if I show you. My bot, it contains at least more than 7 feature. I just give you the references of it, and I give you much or sentence. And this is the first thing. I just calculate using first gram, 1 gram, and after that I give him those information how much it used, and after they call him a function to define how much we swept it, and I give him, and the last thing that you give you the information that my score of based in blue on the main feature it's 0.8, or that I read it in my paper. So after this it will be good if I just jump here and I show you rouge score. So the rouge score, it doesn't contain a large function to be over slap over and over. It's just, you can just, because it's a metric, it just calculate and give the sentence of it, and it give you how much, must go here, it give you all the rouge that has been calculated. I calculate rouge 1, rouge 2, and rouge L, and yes, rouge L as mentioned here, W and S, and every theta has been calculated, where is it? Has been calculated over all the sentence has been used, and every sentence has been calculated over everything as I mentioned earlier. So let's back here and say the first thing, calculation, the rouge contain several parts. We just calculate the rouge 1 is a big gram. And then we, as I mentioned earlier, my bot contains several feature. It's asking for temperature, humidity, denying when the chatbot he didn't would like this. Affirmative when he just would like to accept it. Greeting it only when you would like to say hey and bye. And thanks when you just mention thank you. And sad, it asks about your sad. This is the first has been overcome compared between the blue, it's mean the blue skull, and the orange color, it's mean the rouge. For example, if you can see here, the theta or the sentence when the boat or the user may be asking for the temperature, it contains 0.8 and the rouge, it contains 0.7. So it's mean that our boat has a huge capability because our boat is slipping or maybe extracting between 0.7 and 0.34. So this is for big gram, and this is the second thing for big 2 gram. 2 gram is the sentence, the purpose of it is to understand how much if you just print 2 or double words, how it will be. Here in our boat, it just gives you that 0.8 because our structure has not been used for 2 gram. It was based for big gram because it's much more efficient. And after this, there is another type of rouge. Another type of rouge is L. So the L is the longest common sequences. It reflects how much the proportion of the word will be used in natural comma. So in our, because our main theta is the temperature and the humidity, for that reason, we just would like to compare those, and the other is like a second theta will be used. In this example, the temperature is 0.7, and also in humidity it's 0.7. And based in the structure that's been used in Google, it says that's much more. If the boat has been the capability, it's much more higher than 0.5. It's mean that your boat has a strong capability to understand what the user has been saying earlier, or what we'd like as specific word has been used. And after this, the W rouge. The W rouge, it reflects how much the readability of our boat, and as I mentioned, is provide how much the similarity between the common word. For example, if I say hey, or maybe I say good morning, maybe my bot has been those capability to understand this is the same word has been used or not. In this sentence, or in this example, the temperature has been achieved in 0.58 and the humidity 0.58. It means that our boat has been 50% to understand and define our word. It's based on similarity or not. After this, there is another type of rouge. So 0.5, it means even all of this, it means a great score that we has been achieved. And the list is rouge C and rouge SW. The rouge C, it's used to define the lexical communication between words and how much those words has been connected to each other, how much there is interpretation, and how much those sentence has been correlated with each other. In these cases, we just build a boat that he understands the user. We are not going for a grammatical thing. We are not thinking about all of this. That's why our boat, it just achieved 0.35 in temperature and 0.5 in humidity. It's maybe a good because we don't go further for a grammatical thing, I said earlier. And the listening has been calculated is rouge SW. The rouge SW, it provides how much those words has been linear, I don't know how to explain, connected to each other, and how much is the, as I say, model, it's linear, and how there is interpretation between all those words. So in these cases, we are not building an academy thing. We are just thinking how our bots perform goodly with the user. In this sentence, the score has been achieving For temperature, I always be back for temperature and humidity because it's our main structure based in this both, not the other feature. Maybe it couldn't understand by, but we're just focusing on the main feature or the main sentence has been used. In these cases, it will achieve 0.44 and the humidity is 0.2. And globally, we can say that our boat, it has the average, it just go between 0.3 and 0.7 in the most important thing. And this is, it's mean that our work and our boat has a strong capability to understand human judgment or maybe the dialogue system management, how it will be connected, simulated, and even for define which will be similar or maybe just thinking about what will be there. So after this, after this, there is another type of test has been used. We just as calculating those metric, how it works and how to perform based on the recall has been used. But more important, our bot will provide the good thing if it will be used and communicated with real user. After this, the user satisfaction has been calculated over the paradise savory, as I mentioned in my, as I mentioned, as I mentioned in, as I mentioned as I mentioned in my paper. So it gives you a lot of question. Those question, it's being used in overreaction of the system, how the system, it's been, the average of communication is go from 1 to 5, how the system is able to understand their user or not to use that. Those user has been used from our university, and in the text of effectiveness, how our system is effective. You can see that this user, it have not the same has not the same character or maybe the same thing to analyze. There is some person define that the capability understanding it's higher, the others say that maybe the real feedback is more important, and this thing is based on the user or how it's thinking. That's why you can see the difference between color and also the difference between the user, how it think in over those factors: the task effectiveness, the system capabilities and readability, and the feedback of the user. And after this, it will be very important. I would like to mention how my work, it will be F1 score is achieving 74, the precision is 85, accuracy is 75, the blue is 0.8, which is more important, and the rouge in all system and the main feature is 0.7, and it's a great score that we achieve. Even you have small data compared with the other that has used large and maybe the neural network system use it, we just use machine learning and we achieve good scores. After this, I think this will be much more important if you just conclude our work. So as I mentioned earlier, my bot has been evaluated overlapping, rouge and metric. And also, as I mentioned earlier, the user satisfaction has been calculated over the Paradise survey. The quality of dialogue means that our bot has a huge and great capability to understand the feature using in our structure. Even so, we use just a small data, we achieve a good score. And at least we just maybe think in the future we add much more large data and achieve much more better score. And at least thank you so much for listening and for your time also. And yes. Uh, Thank you so much. Is there any person hear me? I was able to. yeah, there is any question or anything you have to ask me, or maybe you would like to mention it more. I'm not able to hear any person voices. Are you able to hear me?
There is a connection problem, Hajar.
Huh?
Just wait for a horse.
Evet, merhaba. Sunum bitti sanırım.
Bitti. Sorular varsa alabilir.
Hı hı. Yani bir bağlantı problemi yaşadım. Bunun için ayrılmak zorunda kaldım.
Soru yoksa bir sonraki
Evet. Hı hı. Soru yok sanırım.
There is no question, Hajar.
Tamam. Thank you so much for listening. Thank you so much for your time also.
Thanks again.
Thank you.
Next presentation, Hakan Can Altunay. Dear Altunay.
Ya, buradayım hocam.
Tamam.
Finish my work.
Analysis of anomaly detection approaches performed through deep learning methods in SCADA systems. Authors Hakan Can Altunay, Zafer Albayrak, Ahmet Nusret Özalp, and Muhammed Çakmak. Overview, introduction. Number 2, studies using deep learning techniques for anomaly detection in SCADA networks, and conclusions. Introduction. Supervisory control and data acquisition system monitors and controls the industrial systems. SCADA systems use open protocols such as Ethernet and TCP/IP, along with the commercial hardware and software. Today, SCADA systems' ability to connect to the internet and institutional networks causes them to encounter cyber attacks. Cyber attacks are organized against SCADA systems in various files such as nuclear power plants, electrical grids, and water treatment plants. The increase in cyber attacks has led to studies to be carried out towards update protocols, firewall, antivirus software, and closing the gaps in the operating systems in order to ensure safety. In addition to these, standard safety measures, intrusion detection systems have come forward. Intrusion detection systems are used in order to identify the attacks by monitoring the network traffic and computer systems. IDS enables creating a layered architecture to ensure safety when used with other safety instruments. As one of the main safety instruments in ensuring institutional safety, IDS are used in order to detect attacks that cannot be identified by other instruments. In case of a cyber attack threat detected in a network by IDS, information is gathered regarding that threat. The vulnerabilities that might occur upon the access are determined and the threat is prevented by IDS. Reports regarding the prevented threats are sent to the systems administrator by IDS. Upon the analysis of these reports, the security policy can be supervised and measures can be developed for future threats. Classification of the intrusion detection systems according to the analyze method is presented in figure here. Signature-based detection, anomaly-based detection, and hybrid-based detection. Studies using deep learning techniques for anomaly detection in SCADA networks. the one long short-term memory and Bloom filter-based anomaly detection model. Feng and Fritz recommended a model consisting of two detectors and performing data injection attack or denial of service attack-based anomaly detection on the natural gas pipeline SCADA system. The first detector supervises the package signature on the database. Database stores the network's models and communication model signatures in SCADA systems. The package is regarded as abnormal if the Bloom filter doesn't include the signature of the package. The second detector receives the normal package filter through the Bloom filter and supervises the behavior of the next step. This anomaly detection model used in a natural gas pipeline SCADA system correctly detected the attacks at a 92% of rate. Autoencoder-based anomaly detection model. Dietrich and Potluri recommended an autoencoder-based anomaly detection model for the detection of U2R, R2L, DOS, and probe attacks due to an increase in the amount of data and botnet. The autoencoder used in this model has two hidden layers with 10 and 20 nodes. In the study conducted by using the NSLKDD dataset, the number of learned features was given as 10. The model consists of 4 steps as feature learning through autoencoder, supervised training of softmax function, backpropagation training, where data were implemented on L network layers, and classification and testing, where test dataset was provided to the network for the assessments of the model. This recommended approach is used to evaluate the anomaly detection performance in comparison with methods such as K-means, DBN, SOM, and AdaBoost. Autoencoder-based anomaly detection model in smart grids. Smart grids encounter cyber attacks due to the cyber-physical intersection. Anomaly detection models are used to prevent these attacks. Database anomaly detection systems use machine learning techniques. In machine learning, the human handcrafted feature learning process is costly and ineffective in smart grids. Therefore, an autoencoder-based anomaly detection model in smart grids was recommended by Wilson. This method consists of 2 stages. In the first stage, the model is trained offline. In the second stage, it is monitored online. In the offline training stage, previous data are collected for training purposes. Autoencoder is used for feature learning through these data. A classifier is included in the architecture along with the learned features. The entire network is trained by using a supervised backpropagation algorithm. Convolutional neural network and long short-term memory-based anomaly detection model. The secure water treatment tested dataset includes 36 different attacks. The model recommended by Kravchik and Shabtai uses LSTM and a one-dimensional CNN for unsupervised feature learning on this dataset. In this approach, the mean squared error was used as the loss function and Adam optimizer was used for weight reduction, besides preventing the model from overfitting. Adam optimizer is computationally efficient and has little memory requirements. The first deep neural network is LSTM with a fully connected layer used for classification. The size of the layers are determined by identifying the learning speed and degradation value with LSTM. Different core sizes are used in the single layer CNN architecture. Another layer is added after the convolutional layer for the prediction. Convolutional layers are replaced with the inception layer to reach a better performance. Inception layers use sparse networks to reduce the computational load. Convolutional layers, on the other hand, use fully connected networks. Deep belief network-based anomaly detection model in smart grids. Mendis and friends recommended a support vector machine and deep learning-based method to prevent electricity theft. In this method, recommended against false data injection attack, a conditional deep belief network integrating the standard deep belief network with conditional Gaussian Bernoulli was used. The use of conditional deep belief networks shortens the training and testing periods besides enabling the analysis of temporal attack models. The unsupervised learning method is used for the training for the model. A fully connected output layer using the sigmoid activation function, activation function is added, and the entire deep neural network structure is trained with the labeled data by using a backpropagation algorithm. Anomaly detection model using CGB-based deep autoencoder. Zhao and friends recommended an approach performing early anomaly detection and fault analysis to propose a solution for the maintenance costs of the wind turbines. Each wind turbine data is extracted to create a deep autoencoder model using stacked ReDM. The main purpose of using an CGB-based deep autoencoder is to obtain a high rate of change in input data. The backpropagation algorithm is used in the deep autoencoder, and the learning process is conducted. Coded SCADA data are decoded and the reconstruction error is calculated. In the training stage, the deep autoencoder extracts the internal relationships between input and output, and model parameters are set. And finally, anomaly detection model using autoencoder and extreme learning machine. Yan and Yu recommended a deep neural network-based approach for monitoring gas turbine combustors, health, early detecting faults, and identifying abnormal behavior. An extreme learning machine was included in the recommended model. A stacked autoencoder was used for unsupervised feature learning. The feature learned in the autoencoder is sent to the extreme learning machine for the classification process. Training is not required in extreme learning machines, unlike feed-forward neural networks. The extreme learning machine is used to reveal the connections between hidden and output nodes. The only parameter in the extreme learning machine is the number of hidden neurons. Conclusions. Usage of deep learning-based anomaly detection systems in SCADA systems increases day by day with the rapid increase in the amounts of data. The unsupervised feature learning present in deep learning techniques enables important feature learning within the big dataset. Architectures such as convolutional neural networks, autoencoder, deep belief networks, and LSTM are used to learn features of the SCADA data. These architectures use softmax function, extreme learning machine, deep belief networks, and multi-layer detectors in the classification process. The efficient use of deep learning techniques to provide the safety of industry control systems is inevitable in the future. However, although the deep learning techniques have high rates of accuracy in anomaly detection, the long training periods continue to be a disadvantage for these architectures. Distributed deep learning approach can be developed in order to prevent long training periods in future studies. Thanks. Any questions?
Thanks for presentation. Is there any question? Okay.
Diğerine geçeyim hocam. 2 taneydi benim.
Tamam. Ama biraz şey yapalım, toparlayalım. Zamanı aşmayalım çünkü.
Tamam. Network intrusion detection approach based on convolutional neural network. Hakan Can Altunay and Zafer Albayrak. Authors. Overview, introduction, system design, CNN, smooth results and conclusions.
Paylaşımı değiştirebilir misin?
Pardon.
Diğer sunuda kaldı çünkü.
Şu an geliyor mu görüntü?
Yok, şu an paylaşımda herhangi bir şey yok.
Bir saniye. Şimdi geldim hocam.
Geldi.
Network intrusion detection approach based on convolutional neural network. Authors Hakan Can Altunay and Zafer Albayrak. Introduction. Intrusion detection systems are used in order to prevent cyber attacks. These systems identify threats by monitoring data traffic on a network or system. Any identified threat is either conveyed to the system administrator or collected centrally by using a security event management system. Security event management systems combine data from various sources and carry out a filtering process and in this way perform a true or false alarm detection. In this study, it was aimed to identify and classify the attacks on the computer networks by using a convolutional neural network. CSA CIC IDS 1800 dataset was used in our study. Dataset has 82 features apart from label information. Data received by the networks were classified through the recommended method and attack detection accuracy was determined. Synthetic data generation was performed through mode. It was aimed to increase the performance rate in intrusion detection and classification by retraining the entire neural network through synthetic data. Values obtained at the end of the retraining signify that the model properly identified and classified the new intrusion data. Accuracy, precision, and recall values obtained towards the attack detection at the end of the recommended method were presented. In the comparison of these values and the results of other implementations in the literature where deep learning techniques were used, higher performance was reached in attack detection. It was determined that the network performs overlearning in types of attacks with a small amount of data. The overlearning problem was prevented by increasing the number of types of attacks that were low in number within the dataset through synthetic data generation. The recommended method is different from other studies in the literature in detection, the botnet, DOS, SQL injection, and brute force attacks by using a convolutional neural network and synthetic data generation. system design. The recommended design architecture is presented in figure 1. All data must be between 0 and 1 before the testing stage. The normalization process is implemented to the data that are not between 0 and 1 by using a k-means clustering algorithm. Different detection modules are used for feature learning. Feature vectors of the package within each detection module are processed through a convolutional neural network. Learned features are classified in order to create output at the end of the detection process. An output layer fully connected to the CNN was added for the classification process. The algorithm labels the data package upon trade, analyzes when it encounters an attack. Brute force attacks were labeled as 1, DOS attacks as 2, botnet attacks as 3, and SQL injection attacks 4. A new layer is added to the classification process as the number of attacks increases and the entire neural network is retrained. CNN architecture. Two one-dimensional convolutional layers, pooling layer, flatten layer, and ReLU activation function were used in the CNN. In addition, an output layer including two fully connected layers. Epoch was determined as 100 and batch size was determined as 1000. 80% of the attack numbers to be used within the dataset were used for training and 20% were used for testing in the dataset. The label of each sample is determined according to the type of network attack within the related detection model. If the sample doesn't include any attack package, this is called a normal situation. Packages share the same label in a normal situations. In each convolutional layer, the input feature maps are combined to the convolutional core learned during the training process. Then the activation function is implemented in order to create the feature map of the next layer. In the pooling layer, the size of the inputs decreased by summarized on the local values of the feature maps received from the previous layer. Small. The numbers of types attacked in the current dataset are different from each other. Therefore, there is irregularity among the attack packages within the dataset. Data was sampled in the pre-processing stage and the imbalanced distribution within the dataset was eliminated. The sampling process was performed through the synthetic data generation model named SMOTH. SMOTH generates new data by using K nearest neighbors algorithm. In the SMOTH, the difference between the feature vector and the nearest neighbor of the feature vector is multiplied with a random number between 0 and 1. New synthetic data are generated by adding the results obtained to the feature vector. The accuracy, precision, and recall values were obtained as the performance results of the intrusion detection implementation following the training of our algorithm on the dataset. The phi-score performance metric was not analyzed since the precision and recall values were found close to each other. It is observed that the algorithm identified all the samples of the attack classes encountered during the entire training process with high accuracy. The overall detection accuracy is % of 90 8.22. This result signifies that there is a low rate of false positives generated and a small number of samples classified as the normal process. The entire neural network was retrained by performing scientific data generation within the dataset. The overall detection accuracy of the approach following to the retraining was determined as percent of 98.80. The small number of labeled sample causes the accuracy of the model to decrease or the samples of the other classes to be labeled mistakes. The misclassification of the attacks that weren't encountered before prevents the intrusion detection model from identifying the new attacks types occurring. The performance rate of samples of types of attacks within the dataset in terms of classification accuracy during the entire training process is presented in figure. The recommended approach detected and classified the brute force, DOS, botnet attack types with high accuracy. The SQL injection attack samples with 100% classification accuracy, on the other hand, signify that our network has an overlearning problem in the types of attacks with a small amount of data. In order to eliminate the overlearning problem, scientific data generation was performed and the entire neural network was retained with the types of attacks that weren't encountered before. High accuracy was obtained in various attack classes when the model was retrained with attack classes that weren't encountered before. This result signifies that the retraining process step adapts itself to neural network. The performance rate was found 99.1% in the SQL injection trait type of after data was added, while this rate was 100% before the data was added. Therefore, the implemented approach cannot reach accurate results with a small amount of data. Thanks. Any question?
Thanks for your presentation. If there any question? Is there any question? Okay. We can continue next presentation. Dear Şahin. Ali İbrahim Şahin. Okay.
Hello everyone, my name is Halil
Hi.
Ibrahim Şahin. I am a research assistant at Department of Biomedical Engineering in Karabük University. I will try to briefly inform the study we have done with my advisor Ahmet Reşit Kafsoğlu about autonomously controlled intelligent wheelchair system for indoor areas. The content of the presentation will be as follows. First, I will mention about introduction and I will give you some information about simulation environment. And I will explain the shortest pathfinding algorithm used in this study and the visual interface design in this study, movement control system. Finally, I will finish the conclusions and recommendations. I want to start with introduction. Firstly, I will talk about our purpose in this study. Wheelchairs are the most important factor facilitating the life of paraplegic patients who are unable to use their lower body parts below waist. As a result of technological developments, wheelchairs have gained a new dimension to help paraplegic patients. With the addition of a computer and sensors on electric-powered wheelchairs, the intelligent wheelchairs have emerged. In the picture on top, a 3D model of the Faculty of Engineering building of Karabük University is seen, and a photo from a classroom in our faculty is shown in the picture below. Within the scope of this study, our main goal is to design a fully automatic, controlled, intelligent wheelchair for people with walking disabilities. Simulation environment. Coppelia Sim software was used as the simulation software in this study. This software was formerly known as the Virtual Robot Experimentation Platform, VRAP. It can be used in academic studies with free of charge under the new name Coppelia Sim Edu. The educational version has all the features of the commercial version. Therefore, Coppelia Sim Edu software was preferred in this study. There are many scene objects in this software that can be used in interaction with each other. There are also more than one control mechanism in this software. Programming languages like Lua, MATLAB, Octave, C, C++, and C# can also be used with the help of extensions and plugins that provide intermediary connections. For the fourth floor of the building of Engineering Faculty in Karabük University, the two-dimensional floor plan was converted into a three-dimensional model by adding height information. A three-dimensional model of an ordinary wheelchair was used in the simulation. Since there is no need for more visual details in the simulation, a simple model was preferred in this way. At the same time, the simplicity of the model makes the simulation work faster. As you can see on the simulation, it can be simulated by adding more than one randomly moving human model. The screenshot also shows the wheelchair model used in the simulation. We design an interface that can establish a direct connection and communicate with the simulation software. I will talk about the shortest path finding algorithm we used in this study. In jump point search, as it can be understood from the name, jumps are made between nodes that can be reached on the same path. This process results with less computation. In the figure above, it's seen that each node can be reached with only one arrow starting from the start point in the center of the figure. Therefore, each node is processed once. This provides a processing gain in the A-star algorithm by using the jump point search optimization. During the jump point search, it's checked whether there is an obstacle next to the current node to define jump point and stop while jumping consecutively. As seen in the figure at the bottom right, if there is an obstacle shown in black for the node named N, the jump is ended and this node N is called as a jump point. The peculiarity of jumping points is that the shortest path to the node shown in red behind the adjacent obstacle has to pass over itself by only the node N. The path to be traveled between the jumping point nodes calculated by the algorithm and the distance between the nodes are defined. Visual interface. In this study, a visual interface software was developed using C# programming language on Visual Studio development environment. The prepared software uses Microsoft .NET libraries. Our interface software can be run properly by installing it on Windows operating systems. The shortest path between the start and end positions determined by the user can be calculated within the interface software. As seen in the image on the right, the shortest path in the interface software is marked with a yellow line. Intelligent wheelchairs need a map to determine routes in order to work autonomously. While outdoor maps can be found by many applications such as Google Maps, indoor maps cannot be found for every building. Therefore, indoor mapping of buildings is also required. In this study, the mapping of the interior area where the intelligent wheelchair is used was also made. I would like to briefly explain the map creation phase. Two-dimensional drawings of the interior areas need to be converted into a format that can be recognized by the interface software. Two-dimensional drawings of the interior areas need to be converted into a format that can be recognized by the interface software. Two-dimensional drawings prepared in computer-aided drawing programs can be exported in scaled picture format. In the interface software, a monochrome bitmap image consisting of black and white colors can be processed. The image on the left shows the floor plan drawing, the resolution of which corresponds to a 20 cm by 20 cm square per pixel. A close-up of this picture is as seen on the right. This is the first saved image. This image contained half full, half empty pixels. To solve this problem, if a small part of a pixel corresponds to an obstacle, the entire relevant pixel is considered as an obstacle. This pixelization process has brought an important approach in terms of adding extra safety to anti-collision system in this study. When we compare images, all rounded obstacles are flattened as can be seen. A map without rounded corners is obtained. The intelligent wheelchair system can also benefit from camera images while determining the target locations. The camera can determine the current location by reading the QR code tags affixed to the doors of the rooms. For example, while going offices from 417 to 419. A library that processes QR codes is included in the interface software. With the help of QR code labels, all kinds of information can be provided for the interface software. For example, if there is a cleaning, the system can be informed in any way by hanging the closed area information with a QR code. Sugano model was used as fuzzy logic controller. Since there is no diffusification stage in the Sugano model, it gives faster results than the Mandani model. I want to explain the kinetic model of the wheelchair. The variables used in these equations are shown on the figure. Depending on each mother, the new orientation is provided. The speed of the wheelchair is the average of the speeds on the two driving wheels. For x-axis, the change in the x-coordinate is the sum of the x-coordinate at the initial position and the multiplication the time t with wheelchair velocity respect to the x-axis. On the basis of this model, the distance and the orientation angle are used as two main variables. By using these two variables, the fuzzy logic controller is fed and the motor outputs for driving wheels are obtained. The membership functions used are as follows. Input membership functions used for distance and angle are shown above. The equivalent output membership functions according to the Mandani model are shown below as singletons. When a command is sent to the motor driver microcontroller used in the wheelchair, the speed of the wheelchair is gradually increased to the target speed by the microcontroller. The fuzzy rule list used for left and right wheels is shown. There are left and right motor speed outputs depending on the distance and orientation inputs. As a result, within the scope of this study, an add-on that makes an ordinary electric-powered wheelchair into a fully autonomous wheelchair has been designed. These attachments can also be applied to any wheelchair. The prepared system can be used in any environment. For this, it's necessary to map the relevant environment. Environment maps can be downloaded over the wireless network. This ensures that the system remains up to date. This feature can also be used to notify the system of sudden changes. When receiving commands from the user or warning the user, microphone and earphone can be used as an alternative to the monitor. While receiving location information, the user's audio signals can be processed and converted into inputs. An auxiliary arm can be added to open obstacles such as doors. The jump point search optimization of the A-star algorithm used in the study makes the user wait for a certain period of time to calculate the shortest path. Pre-rendered maps can be used to reduce waiting time. There are different algorithms on this subject in the literature. In our study, the shortest path is found on maps that have not been processed before. On the other hand, our control system can be improved. Wheelchairs have dynamic constraints. There are situations that cause instability, such as wheel slip. It can be extremely unstable at high translational speeds. At this stage, the dynamic model can be improved by making it more complex. Thank you for listening to me.
Thanks for presentation. Next presentation, Dear Camcım.
Merhabalar, sesim geliyor mu acaba?
Geldi, sıkıntı yok.
Ekranım görünüyor mu?
Ha, o da geldi.
Merhabalar, ismim Hasan Camcı. Karabük Üniversitesi'nde Biyomedikal Mühendisliği bölümünde yüksek lisans öğrencisiyim. Bugün sizlere geliştirmiş olduğumuz işitme engellilere yönelik çevresel ses yönü tespit sisteminin sunumunu gerçekleştireceğim. Öncelikle sunumumun içeriğinden bahsedeyim. Sunumuma giriş kısmıyla gerçekleştirilen çalışma hakkında genel bilgi vererek başlayacağım. Sonrasında materyal ve metot kısmında çalışmada oluşturulan ve kullanılan veri setinden, tasarlanan arayüzden, C# programlama dilinde makine öğrenmesi algoritması kullanmamıza olanak sağlayan ML.NET kütüphanesinden ve bu ML.NET kütüphanesi kullanılarak oluşturulan modelden, Perceptron modelinden bahsedeceğim. Son kısımda da çalışmanın sonuçlarına yer vereceğim. Giriş kısmıyla başlayalım. Türkiye'de işitme engelli yaklaşık 3 milyon kişi vardır. Dünyada ise bu sayının 76 milyon olduğu düşünülmektedir. Ancak bu sayıya işitme güçlüğü çekenlerin sayısının eklenmesiyle 500 milyon insanın günlük hayatta işitme problemleri ile karşı karşıya kaldığı, bununla beraber hem sosyal hem psikolojik olarak hayat kalitesinin düşmesine neden olduğu tespit edilmiştir. Bizim de bu çalışmadaki amacımız işitme engelli bireylerin günlük hayatta sesin nereden geldiğini bilememesinden dolayı yaşadıkları zorlukları giderebilmektir. Buna en basit şekilde bir örnek vermek gerekirse, tehlike oluşturabilecek bir köpek sesine işitme engelli bireylerin tepki gösterememesine verebiliriz. Yapılan bu çalışmada işitme engelli bireylerin hayat kalitesini arttırmaya yönelik çevresel ses yönü tespit sistemi önerilmektedir. Önerilen bu sistemde insan kulakları baz alınarak 2 adet mikrofon ile 8 farklı yönden elde edilen ses verileri filtreleme ve öz nitelik çıkarımı işlemlerinden sonra yapay sinir ağı algoritması uygulanarak %87,5 başarı oranı ile ses yönü tespit edilebilmiştir. Biz bu çalışmada insan kulak sayısı kadar mikrofon ile sesin geldiği yönü tespit edebildik. Materyal metot kısmına geçelim. Bu çalışmada yapay bir ses algılama ortamı oluşturulmuş. Oluşturan bu ortamda 8 bölgeye ayrılan platform ortasına insan kafa mankeni kulaklarına da 2 adet mikrofon yerleştirilmiştir. Bu mikrofonlar aracılığıyla kaydedilen çevresel ses verileri USB ses kartları kullanılarak Dattapanda tek kart bilgisayara aktarılmıştır. Dattapanda tek kart bilgisayarda yüklü bulunan C# arayüz tasarımı ile ses sinyallerinden elde edilen öz nitelikler gerçek zamanlı görüntülenmekte ve ml.net kütüphanesi kullanılarak sesin geldiği bölge C# arayüzünde gösterilmektedir. Çalışmanın prototip aşamasında çevresel ses kaynağı oluşturulan platformdaki 8 farklı bölgeye Bluetooth hoparlör konumlandırılarak sağlanmıştır. Bu kısımda da çalışmamızın prototip şeması görülmektedir. Çalışmamızın prototip aşamasında bir platform oluşturuldu. Oluşturulan platform 8 eşit bölgeye, yani dikdörtgensel olarak ayrıldı. Ortaya insan kafası, mankeni ve kulaktan mikrofonla entegre edildi. Sonrasında bu 8 bölgeden herhangi birine hoparlör konumlandırılıp ses kayıtları elde edilerek bu ses kayıtları da ses kartları ile Lattafan'da tek kart bilgisayara aktarıldı. Aktarmanın sonrasında sesin geldiği bölge şekilde görüldüğü gibi kullanıcıya, yani burada yeşil daire olarak döndürülmüştür. Bu kısımda da makine öğrenmesinde eğitim kümesi olarak kullanılan veri setinin nasıl elde edildiğinden bahsedeceğim. Veri seti oluşturulurken daha önce bahsedilen platform üzerindeki 1'den 8'e kadar numaralandırılmış bölgelerin her birine çevresel ses kaynağı olarak Bluetooth hoparlör yerleştirilerek 8'er saniyelik kayıtlar alınmıştır. Bu kayıtlar alınırken hoparlör her bölge için 3 ayrı konumda 4 farklı ses seviyesinde olmak üzere toplamda 96 farklı ses kaydı elde edilmiştir. Elde edilen ses verileri filtreleme ve özne tek çıkarım aşamalarından geçirilerek makine öğrenmesi için elverişli veriler haline getirilmiştir. Kullanılan veri setinde toplamda 15 öz nitelik, dil bölge etiketi ve 96 deneme olmak üzere 96 satır ve 16 sütundan oluşmaktadır. Veri seti elde etmeyi de ileride bahsedeceğim tasarlanan arayüz sayesinde gerçekleştiriyoruz. Burada da arayüzde verileri görmek için kullanılan Data Grid View tablosu görülmekte. Bahsettiğim üzere 15 adet öz nitelik, 1 adet bölge etiketi bulunmakta. Buradaki ilk 8 veri setimizin ilk formasyonu, yani ilk 8 denememiz. Bunun da her bölge için orta konumda en düşük ses seviyesi için elde edilen değerler. Bu işlem sonrasında her bölge için 3 ayrı konum ve 4 farklı ses seviyesi olmak üzere toplamda 96 satır veri elde edilmesinde sağlanacak. Bunu isterseniz bir önceki fotoğrafta tekrar göstereyim. Kafa mankeni sabit tutulma kaydıyla sırayla hoparlörü öncelikle her konumun ortasına ve 4 farklı seviyenin ilk en düşük seviyesinde tutarak 8'er saniyelik kayıtlar alarak veri setine aktarıyoruz. Sonrasında aynı işlemi diğer 3 farklı seviyede gerçekleştiriyoruz. Daha sonra bu sefer konumu değiştiriyoruz. Ses seviyesini sabit tutup bunda da hoparlör, mikrofon, yani kafa mankeni en yakın konuma ve en uzak konuma yerleştirilerek diğer veri seti denemeleri de elde edilmiş oluyor. Böylelikle 96 satırlık veri setimizi oluşturuyoruz. Arayüz kısmına bahsedeyim arayüzden. Önceki kısımlarda da değinmiştim zaten. C# programlama dilinde tasarlanan arayüz sayesinde ön işleme, öz nitelik çıkarma ve veri seti oluşturma işlemini gerçekleştirebilmektedir. Daha önce bahsedilen 96 satır ve 16 sütundan oluşan veri seti arayüz kullanılarak elde edilmiştir. Oluşturulan bu arayüz sistem modeli geliştirilmesine yönelik veri seti hazırlamak için farklı denemelerin yapabilmesini sağlamaktadır. Veri seti kısmında da bahsettiğim üzere veri setini sürekli yeni denemeler yaparak, yeni kayıtlar alarak yeni değerler ekleyebiliriz. Mesela ben 3 farklı konumda yaptım. Bunu 5 farklı konuma daha fazla platforma büyüterek sağlayabiliriz. Arayüz ile oluşturulan .csv uzantılı veri seti ml.net Model Builder'da kullanılarak sistem için en başarılı model elde edilmektedir. Sonrasında bu model kullanılarak çevresel ses yönü tespiti gerçekleştirilebilmektedir. Burada da arayüzümüz görülmekte. Arayüzümüzdeki butonlarda kaydı başlat 8'er saniyelik kaydı başlatmak için kullanılır. Nitelik çıkar kayıt sonrası elde edilen verilerden 15 adet öz nitelik çıkarmak için kullanılmaktadır. Tabloya aktar her denemede çıkartan öz nitelikleri veri setine eklemek için, yani bu şekilde görüldüğü üzere Data Grid View'de kullanıcının görebilmesi için tüm denemeler bittikten sonra hepsi alt alta böyle biriktikten sonra tüm denemelerden sonra Excel aktar butonuyla da .csv formatında kaydedilmektedir. Burada da oluşturulan model sonrasında döndürülen sonuç sesin geldiği yön kullanıcıya şu şekilde gösterilmektedir. 8 farklı bölge olarak. Şimdi oluşturulan makine öğrenmesi modelinden ve kullanılan algoritmadan bahsedeyim. Öncelikle genel olarak ml.net'ten bahsetmek istiyorum. ml.net, C# ve F# programlama dilleri için makine öğrenmesinin uygulanabileceği ilk sürümü 7 Mayıs 2018 tarihinde çıkan bir yazılım kütüphanesidir. ml.net bir makine öğrenme modelidir. Model giriş verilerini bir tahmine dönüştürmek için gereken adımları kullanıcıya sunar. ml.net kullanılarak belirtilen algoritmaya göre modelin eğitilmesi veya önceden eğitilmiş modellerin çevrim içi olarak elde edilmesi mümkündür. Kullanıcılar modeli elde ettikten sonra tahminleri yapmak için modeli projelerine ekleyebilmektedir. ML.NET yani kullanıcılara veri setini eğitme, test etme ve veri setine uygun en başarılı algoritmayı tespit etmesini sağlıyor. Bu çalışmada kullanılan verileri en uygun ve en yüksek başarı oranı sağlayacak algoritma ML.NET Model Builder tarafından Perceptron tek katmanlı yapay sinir ağı algoritması olarak belirlenmiştir. Perceptron denetimli bir öğrenme algoritmasıdır. Yani ağa hem giriş hem de çıkış kümesi verilir ve öğrenme beklenilir. Perceptron modelinde en önemli faktör eşik değeridir. Bu değer kullanılarak başarılı bir sınıflandırma yapılabilmektedir. Saptanacak olan eşik değeri probleme göre belirlenebilir. Eşik değeri sınıflandırmanın başarılı olduğunu belirleyen faktördür. Eşik değeri giriş değerleriyle ağırlık değerlerinin çarpımı sonucunda çıkan değerin 1 veya 0 olarak döndürüleceğini belirlemektedir. Eğer giriş değerleriyle ağırlık değerlerinin çarpımları toplamı eşik değerinden büyükse 1, küçükse 0 değeri döndürülmektedir. Hata oranı giriş değerlerine verilen ağırlık değerlerinin doğru değerler olmamasından kaynaklanmaktadır. Ağırlık değerlerinin hata oranı azaltana kadar eğitilmesi ve buna göre yenilenmesi gerekmektedir. Burada zaten en basit yapay sinir ağı temelini göstermekte. Buradaki X1 girişlerini weight'leri eğiterek nöron olarak çıktısını görmekteyiz. Burada da eğer eşik değerinden büyükse 1, küçükse 0 değerinin döndürüldüğünü bahsediyor. Sonuçlara gelirsek, bu çalışmada oluşturan sistem prototipi üzerinden Bluetooth hoparlörün 8 farklı bölgeye sırasıyla yerleştirilmesiyle her bölge için 3 ayrı konumda ve 4 farklı ses seviyesinde kaydedilen ses verileriyle elde edilen ML.NET Model Builder kullanılarak makine öğrenmesi modeli oluşturulmuştur. ML.NET Model Builder kullanılarak oluşturulan modelde en yüksek başarı oranına sahip tek katmanlı Perceptron algoritması kullanılmıştır. Aşağıda bu her bir algoritmanın başarı yüzdeleri görülmektedir. Diğer denenen algoritmalar başarı sırasıyla doğrusal destek vektör makinesi, olasılıksal dereceli azalma, çok katmanlı Perceptron ve karar ağaçları olmuştur. Tek katmanlı Perceptron algoritması oluşturan bu sistem modeli 87,5 başarı oranıyla çevresel söz yönü tespit edebilmektedir. Beni dinlediğiniz için teşekkürler. Sunumum burada sonlanıyor.
Teşekkürler. Bir sonraki sunumdan devam edelim. Ferda Ünal sanırım. Mikrofonunuz kapalı şu an.
Fundamental studies, results, and conclusion. Educational data mining is an emerging discipline concerned with developing methods for exploring the unique and increasingly large data that come from educational settings. Educational data is taken from students' use of interactive learning environments, computer-supported collaborative learning, or administrative data from schools and universities. Before SSOC, let's take a look at semi-supervised learning and ordinal classification. Semi-supervised learning is an important and useful type of machine learning concerned with using both labeled and unlabeled data to perform a particular learning task. It is conceptually situated between unsupervised learning and supervised learning. The semi-supervised learning topic has received much attention in many areas ranging from health to education. Ordinal classification is a special kind of supervised multi-class classification task that addresses the class attributes whose labels exhibit a form of ordering. For example, an ordinal class attribute can represent 4 wind level categories in a wind speed prediction problem. That's very high, high, moderate, and low. Semi-supervised ordinal classification combines both semi-supervised learning and ordinal classification approach. This is a new classification strategy for incorporating ordinal data information into semi-supervised learning. This method considers the hierarchical relationship among the target variables when using both labels and unlabeled ordinal data for classification. SSOC method is able to use unlabeled data along with the labeled ordinal data to construct more efficient models in terms of accuracy compared to standard ordinal classification methods. This slide shows the SSOC algorithm. The SSOC method consists of the several main steps. The first stage is to train multiple binary classifiers on the existing labeled ordinal data. After that, the unlabeled data is labeled by the constructed classifiers via their predictions to generate additional labeled data, which is commonly referred to as pseudo-labeled data. Lastly, the final inductive classifier is built by using both originally labeled and pseudo-labeled ordinal data. At the end, make these all steps for 5 times and find this result average. This figure shows the proposed educational data mining process. Educational data and then data pre-processing, semi-supervised ordinal classification, that's training, and last evaluation. Experimental studies. We conducted an experiment on 3 ordinal educational data sets for illustrating the efficiency of the proposed SSOC algorithm. The datasets used in this study have an ordinal categorical structure. We investigated the performance of the SSOC method with different ratios of labeled data from 15% to 50% with 5% increments and finally as 75% to determine its impact on the method. We evaluated the performance of the SSOC method with different base classifier combinations, that's decision tree, random forest, and neural networks. And we used Becker classifier, ordinal class classifier library for ordinal part. We compared the SSOC method with the traditional OC method on 50% labeled data in terms of accuracy. Dataset description. This table shows 3 datasets description. These datasets suitable for ordinal classification and related to the field of education. The first dataset named XAPI-EDU was obtained from the Tegel data repository. It contains some demographic behavioral features and information about academic achievements of the students. This data was collected from an e-learning system. The target attribute in the dataset involves ordinal class labels about student performance, like low level, middle level, and high level. The second and third datasets named student math and student core were obtained from the UCI machine learning repository. These datasets also contain student academic performance information from mathematics and Portuguese language course. In these datasets, the final score is ranged between 0 and 20, making and that's very difficult to make a prediction. So some data preprocessing activities were performed on the datasets. The final score was graded according to the ordinal structure, such that the range 0 to 9 expressing F, 10 to 11 expressing E, 12 to 13 expressing C, 14 to 15 expressing B, and 16 to 20 expressing A. In order to investigate the effectiveness of SSOC on educational data, several experiments had been carried out. Each dataset was considered as labeled and unlabeled at certain rates, and the results obtained with various ratios of labeled data were compared. We took into consideration different percentage values when partitioning the datasets. This figure shows the accuracy values obtained by the application of the SSOC-VT, SSOC-RF, SSOC-NN methods on the first dataset. Although there is not much difference in performance of SSOC-NN and SSOC-RF, it's possible to say that the SSOC-NN method is more likely to classify correct the more many ratios of labeled data. As expected, the performance of all the methods improved as the number of labeled data instances increased. The best accuracy, 92%, was obtained by SSOC-RF. It seems that decision tree is not a good choice to be used with SSOC since their conjunction showed the worst performance for this dataset. These figures show the comparison of the performance of the SSOC-VT, SSOC-RF, and SSOC-NN methods on the second and third datasets. Random forest-based SSOC method always issued the best results for both of the datasets. Another remarkable point here is that even with 15% labeled data, an accuracy of 71% was obtained in the third dataset. Thereby, it can be concluded that it's possible to achieve high accuracy values by SSOC-RF when a very small amount of labeled ordinal data is available. The highest accuracy value, 93%, obtained by SSOC-RF for dataset 3. The reason is probably because RF is random forest is an assembled style learning algorithm and usually increases accuracy by combining the output of minimization trees. This table shows the F-score values obtained by the SSOC basic method on the 25%, 50% and 75% labeled data of 3 datasets. F-score is ranged from 0 to 1, and 1 is the best value. For datasets, dataset 1 and F-score value of 0.93 was obtained by SSOC RF. As has been observed for dataset 2, the highest F-score value 0.92. For dataset 3, the highest performance 0.93. As a result, SSO RF usually achieved better accuracy than the rest. In this experiment, we compared the SSOC method with the traditional OC method on 50% labeled data in terms of accuracy. This figure shows the results side by side for the same base learners, SSOC on the left and OC on the right, separately for each dataset. As can be observed, SSOC outperformed OC by obtaining higher accuracy values in all cases. For each dataset and with each base learners, SSOC provided accuracy again higher accuracy against OC. This study proposes the use of semi-supervised ordinal classification in the field of education for the first time. It solves two important problems: the scarcity of labeled data in the field of education and the requirement of considering the ordinal structure in educational data. In the experimental studies, 3 publicly available datasets and 3 different base learners were used to test SSOC. We conducted several experiments on ordinal student datasets with different quantities of labeled, unlabeled instances. Overall, good results were obtained in all the datasets. According to the results, SSO outperformed the standard ordinal classification in terms of accuracy. Finally, as a suggestion for further studies, the SSOC approach can also be applied to solve different educational problems rather than student performance classification. These are our references. And thank you.
Evet, bir sonraki sorudan devam edelim. Burkay Karadayı, onun yerine Yusuf Kuvvetli mi?
Evet, doğrudur hocam.
Tamam.
Burkay'ı dün evlendirdik. O yüzden sunumu ben yapıyorum.
Hayırlı uğurlu olsun.
Sağ olun. Pandemi nedeniyle böyle acil gerçekleşen bir durum oldu biliyorsunuz. Onun yerine ben yapacağım sunumu. Uygun görürsünüz.
Böyle sıkıntı yok.
Teşekkür ederim. Başlıyorum o zaman ben.
Tabii buyurun.
First of all, I wish you all healthy days during the pandemic. We had planned this presentation handled by one of our authors, Burkay Karaday, but since he got married yesterday, so I will do this presentation. My name is Yusuf Kuvvetli. I'm an associate professor at Çukurova University Industrial Engineering Department. Today, I'm going to talk about our paper named as Fault-Related Alarm Detection of a Wind Turbine SCADA System. When we check the contents, since similar studies are described, I will prefer to give a more conscious explanations. First of all, in the introduction, I will briefly talk about the renewable energy sources and the wind turbines. Then the methodology will be explained, which includes a pre-processing applications for eliminating irrelevant parameters from our data set, and the class balancing method, which we use SMOT method in the study, and finally, the classification technique, which we prefer two of basic classification algorithms, which are decision trees and support vector machine classifiers. Finally, the results of our application is presented. Renewable energy sources reach more attention and more installed daily power due to the lack of non-sustainable energy sources, such as fossil-based energy sources. Also, wind energy has an important impact on increasing the portion of the renewable energy sources worldwide. Both onshore and offshore wind farms are the second most significant increasing portion of renewable sources after hydropower. As you can see in the figure 1, wind power has a great potential, and also the data of this figure is obtained from International Renewable Energy Agency dataset. Also, in the figure 2, it's shown that the installed capacity levels are increased from about 0 megawatt to 700,000 megawatts between 2000 and 2020. It shows us that wind energy has a good potential. In the production of wind energy, there are different faults, and one of the important problems is diagnosis this faults. This fault diagnosis is a critical topic, and it's important for condition monitoring, maintenance planning, and determining the wind turbines' remaining useful lives. And there are different methods such as vibration analysis, noise analysis, oil analysis, and data analysis. Data analysis is preferred one because SCADA systems, supervisory control and data equation systems, bases on data analysis and doesn't need any extra sensor investment costs. So it's a cost-efficient method. Therefore, we select this data analysis method in our study. SCADA system alarms can give insight about failures to the system operators. These alarms could be about the central system problems or subsystems problems of a wind turbine. The alarms should not be only about the equipment failures, but also could be about the environmental and other operational conditions. So these alarm conditions prediction problem is important during the daily operations of wind turbines. In the literature, we found different studies about these aspects, and they consider different prediction methods such as artificial neural network based methods and some deep learning methods. We found that, and also some practical tools such as failure modes and effect analysis method, FMA methods known as. And we prefer using a more complex methodology to four-step methodology, as you can see in figure 4. The first step is about the data equation. In this context, the SCADA system of a wind power plant has been determined as 10-minute interval data set, as it is based on some studies in the literature. All data in wind power plant about the 1st January and between the 1st January and 1st March 2021. And the data constitutes of two different type of data, which are alarm condition and the operational data. Operational data also includes data about the gearbox, generator, transformers, hydraulic system, and the other relevant systems, like the other previous studies. After the data equation, we should analyze the data, and we should make a pre-processing to our data. In the pre-processing step, we use the firstly we have to balance our class in order to avoid misclassification. If a class has a majority from the other one or the other ones, then all of our machine learning methods tends to select all of the outputs as the major class. So we should balance our classes before the analysis. So we firstly we use this balancing method. We use SMOT, and after the SMOT application, we have a balanced data set, and this data set can be used and input for the feature selection application. Since our data is recorded with many different variables and parameters due to the SCADA system complexity, feature selection becomes essential, a system like our systems. And we use an extremely randomized tree method for the feature selection, and it's a very useful method for the feature selection. I will be explaining it later. And in the classification, we prefer two different classification methods, which are support vector machine classifiers and the decision tree classification approaches. And support vector machine classification is a classification method, which is similar to logistic regression method. They both try to find the best line separating the two classes or more classes. The algorithm ensures that the line to be drawn is set to pass the farthest place to its elements in two classes. Thereby, it's a non-parametric classifier that takes no parameter. And the decision tree algorithm is a method like flowchart based representation, where an internal node represents our features or attributes, and the branch represents a decision rule, and each leaf node represents the outcome. and the topmost node in a decision tree is known as the root node. To make an optimal tree structure, different algorithms can be used, which we used ID3 algorithm in the study to make a better classification using the decision tree methods. And after that, we have a performance analysis step. In this step, we use area under curve and receiver operator characteristic curve metrics, and also confusion matrix and F1 scores in order to obtain the best classification method. When the data is examined, it's defined that it has 128 input variables and 8,496 data samples we have. So it's hard to show all of our 128 input variables, but you can find the alarm situation in our system in this table, table 1. And according to our system, the alarm condition is marked as 1 and non-alarm condition is marked as 0. So the probability of an alarm is calculated about 1%, and which means that there is no balance between the classes. So we use smooth methodology. In the smooth methodology, there are 3 situations we can consider to balance our major class with the minor class. And the first one, removing data from the major class. And the second one is adding data to minor class. And the third one is both removing data from the major class and adding data to minor class. Since we have a huge difference between our major and minor class, then we prefer the third one, and we in our study we apply the smooth algorithm with oversampling ratio by 0.1 and the undersampling ratio for the major class with the ratio 0.5, and after that we found more balanced class and we use that alarm conditions in our analysis. After the smooth method, we have to find the feature selection results to make the overall classification algorithms. We have 128 input parameters in our system, and now we reduced these parameters to 51 input parameters after the extremely randomized tree algorithm is applied to the data set. Extremely randomized tree algorithm consists of randomizing strongly both attributes and the cut points choice while splitting a tree node. In more clearly, in the extreme case, it builds totally randomized trees and whose structures are independent of the output values of the learning sample. The strength of the randomization can be tuned to problem specifics and it can be useful for the parameter choice problem. So we use that approach. And when we apply the support vector decision tree classifier to our data set, we use 5-fold cross-validation to our data set, and the area under curve values are vary between 84 and 88, I think, % in our all data set. It shows that the prediction seems a high accuracy. According to the support vector machine application, the area under curve values are more robust and they vary from, I think, 85 and 86%, which also have a high accuracy in the classification. It can be concluded that both methods are close classification performance. So let's check the other performance measures to find the best classification method. And according to the comparison of these other performance metrics such as accuracy, specificity, recall, precision, and F1, decision tree algorithm is better than support vector classifier for all performance measures, and especially in the accuracy and recall performance criteria, also F1 criteria, decision tree has a more suitable results than the support vector machine classifier. And for the future studies, we try to find an adaptive method that bases on the different applications, such as deep learning algorithms and artificial neural networks, some of the extensive artificial neural network algorithms. And we plan to provide a tool for real case applications. And this study is also part of a PhD thesis of Burkay. So we will be develop our solution methodology in our future cases. Thank you for listening me. If you have any questions or comments, I would be appreciate to hear from you. And these are our reference of our study.
Thanks for presentation.
You're welcome.
Next presentation, Caner Baydur.
Merhabalar, sesim geliyor mu hocam?
Geliyor, sıkıntı yok.
Tamamdır, açıyorum. Gözüküyor da.
Geldi.
Tamamdır.
Hello, my name is Caner. I'm electrical and electronic engineering student of İzmir Keldik Çelebi University. My project name is ARM-based smart water meter with Hora for soilless agriculture application. Before starting my presentation, I would like to express my special thanks to my supervisor, Associated Professor Savaş Şahin, for patient motivation and continuous support. Also, other special thanks goes to my co-supervisors, Mr. Bahadır Yeşil and Alkım Gökçen, for their guidance and helping me in every step of project. Also, this work is supported by the Scientific and Technical Research Council of Turkey under Beckley Final Thesis focused on industry program. My presentation section: Introduction, Material and Method, Flowchart of the system, System overview, differences from other systems, main interface and results, conclusions and future works. This purpose system is consists of two different embedded systems where the necessary parameters are measured, actuators are controlled, and related input-output pairs are observed. The yield of the nitrogen solution in the system is continuously controlled, and the necessary conditions are provided for the growth of the product in the greenhouse. The microcontroller system is responsible for data transmission in the greenhouse. LoRa communication is employed to construct a data flow network between embedded systems. A control unit is positioned in the greenhouse where the relevant input-outputs of the embedded system can be read. The sensor and actuators that are obtained during the studies, the necessary conditions for soilless agriculture are examined and the results are presented. ARM-based STM32-bit microcontroller with low power consumption was used in the purpose project. The pH, conductivity, and temperature value of the nitrogen solution are checked. In addition, the temperature value of the greenhouse is also controlled. If it is out of the specific range, the relevant relay is activated. There is a motor inside the related relay to prevent from being affected by the magnetic field. Therefore, the relay is activated and deactivated by the motor driver. The obtained data is transmitted to smart water meters and nutrition solution is added according to the pH value. All data is sent to the computer after the smart water meters. The pH sensor measures the hydrogen ion concentration in the nutrition solution. This device determines whether the nutrition solution is acidic or basic. Measurement pH range is 0 to 40 and sensor supports 5 volt voltage supply input. Operation temperature range 0 to 60 centigrade. Solution temperature sensor is used to measure the temperature of the nitrogen solution. Measurement range is -50 to 250 centigrade and sensor supports 3 to 5 volt voltage supply. Conductivity sensor. The conductivity sensor can be used to measure the electrical conductivity of the solution and assess water quality. The desired values are obtained by computing the voltage drop rates on voltage divider circuit. Temperature measurement range is -55 to 350. Relay employed to the control motors by an on-off process. It has maximum switching voltage of the 250 volt AC and rated carrying current up to 120 amps. The relay is turned on and off by turning the motor inside. It maintains either contact position indefinitely without power applied to the motor. Thus, a motor driver circuit is designed and employed. Flow chart of the system. Firstly, microcontroller wakes up from the sleep mode every hour. Check the calibration of the pH and conductivity sensor. And then control the calibration if it is time to calibration. If it is time to calibrate, then send data to computer. If it is not, read data from sensor. Here, check the what range its temperature is in. According to the result, open ventilation or hot air pump, then sends data to water meters. Here, check the data and when the microcontroller receives the data, water meters again check the what range pH value is in. So as a result, water meters turn on the valves. Differences from other systems. Adaptability. We can easily add new sensors or other things. We can send data to any gateway, then it consists IoT. Less costly than other systems. It consists wireless communication. We can send data up to 220 kilometers away. Easy to maintain. Low power consumption. Here is the system overview. LoRa module, microcontroller, microprocessor, temperature sensor, solution temperature sensor, conductivity sensor, pH sensor, motor driver circuit, and relay. Here, lettuce is chosen to grow in the purpose system and it is purposed to keep the nutrition solution specific parameters in the desired range. The sampling period of the necessary parameters is 1 hour. The required pH range for the lettuce is 6 to 7 and the AC range is 800 and 1200. The microcontroller transmits the data to the smart water meters with the LoRa module. The data are transmitted to the computer via UART for monitoring. If It can be viewed through an interface made in the MATLAB App Designer. As it might be seen, the change of the pH and AC were observed. Parameter changes didn't exceed the specific ranges, and the continuity of the desired nutrition solution was ensured. Also, lettuce's rooting and grow with the purposed system in the healthy way might be observed. Conclusions and the future work. In this study, an alternative design to the system used in the traditional greenhouse agriculture and the soil agriculture is employed and tested. For the plant grown in the soil agriculture, the nutrition solution should be controlled and monitored precisely. This requirement is provided with LoRa module, which is connected to the ARM-based microcontroller unit. The data received from the module in the field are transmitted to the meters, and in this way, nutrition solution is to be controlled in the desired range. A lettuce growing application was performed, details of the procedure was explained, and the results were presented. Results indicate that purpose system showed a sufficient performance on both process control and communication tests. Also, a lettuce is successfully grown in the research period. In the future direction, a machine learning based method might be employed to analyze and construct the relation between nutrition solution parameters and growth. Thank you for your attention.
Soru varsa alabilirim hocam. Turgut hocam orada mısınız?
Buradayım burada. Sunumların tamamı bitti zaten. Soracağınız herhangi bir şey varsa cevaplandıralım. Yoksa oturumu sonlandıracağım.
Teşekkür ederiz hocam.
Ben teşekkür ederim. Sağ olun.
Evet, katkılarınız için hepinize ayrı ayrı teşekkür ediyorum. Bugün son bir oturumumuz kaldı. Daha 6'da başlayacak. 6 çeyrekte. Yaklaşmış o da zaten. Ondan sonra kongreyi sonlandıracağız. Tekrar teşekkürler.
Teşekkürler herkese.
Biz teşekkür ederiz.
Üzerine sağlık.
İyi çalışmalar.
İyi çalışmalar hocam.